Good morning, everyone. In the last session, we discussed about the basic important the root level interface called collection here. Now, the collection is having these many methods here. Okay, we'll try to identify how this each and every method implemented internally. But so whenever we are trying to discuss about this particular collection framework, now we identified collection is one of the root interface. From this particular root interface, we'll try to extend some sub interfaces here. So what are the sub interfaces we are having here? Now the second one is, because yesterday we completed the collection interface. So today we'll discuss about the another important interface called. Now here, so collection we identified here. Now we need to understand about the list here. We need to understand about the list interface. Now if you see this, now if you observe carefully, list is also another interface. List is also another interface. Now if you observe extending collection interface. So yesterday, whatever the collection interface we discussed here, now the list is extending collection interface. Now what is the hierarchy basically? The hierarchy here, this is the root interface. From this particular root interface, now we are extending this particular list interface here. Okay, so this is something like a sub interface. This is the super interface here. So far we are having so one-to-one relation here. Getting the one. So something like one super interface and one sub interface here. But in after completion of this particular list interface, so this hierarchy it is going to be changed here. But now observe carefully. So when we are trying to discuss about this particular list here, again into size here. Okay, into size. Now whatever the method we discuss here, this is also same into size. So what exactly the into size method will do? So it will try to return the count to how many elements are inserted into this particular list here. So is empty. So is empty contains method. So most of the methods are extending from this particular collection interface. Most of them are already available from this particular collection interface. So to understand this, what you need to understand basically, now here you can see here. So this is very important. We need to understand into size method. So we already copy this into size method, and the same thing. Now if you see boolean is empty. So this is a is empty. Now what it will do? It will try to check whether this particular collection or whether this particular list so does not contain any element. Then it will try to return as a true. Otherwise it will try to return as a false here. Okay. So to check the given collection is empty or not. So which collection now? So here we need to check on the list related. Okay. So same thing. Now if you go to this particular contains, here also we are having same method. Okay. So even though you are extending from this particular super interface, the method is same. Okay. Now here you can see iterator. Now to array. Now whatever we discussed in the yesterday. Now here you can see this is also the type related array method here. Now add method. So this is the boolean add method which is expecting one parameter, that is a generic type e. So here we added this. Now if you see here boolean add e. Now what exactly it is saying here? We are going to use this particular add method to insert the record into this particular collection. Okay, so currently these are the interfaces. Directly we cannot use this particular add method because these add methods are just declared here, so it is not implemented here. Now when these are going to be implemented? Whenever we are trying to discuss about the implementation class. Okay, now we need to understand here. So whenever we are going to discuss about the implementation classes, so there we'll try to focus more about the how the each and every method is implemented internally. But so far what you need to understand, what are the different type of method we are having for this particular collection interfaces here. Okay, so add method and remove method, same remove method. Now what you observe carefully, so currently whatever the method we are seeing under the list also, all the methods are come from the collection interface. Contains all method. Now add all method, these are the same method. Now if you see add all, one more method we are having which is expecting two parameters, which is expecting two parameters. Now if you see here After this, here I'm trying to define list interface. Now here it is expecting the generic type E, and internally it is extending from collection interface. The collection is also internally extending particular generic type here. Okay, so now carefully observe, this is the specific method we are having under this particular list interface. So far, if you observe, all the methods are expecting one parameter. Contains method is also expecting one parameter. Now here you can see this is a one parameter, and this is also one parameter, and this is also one parameter. Now here you can see remove if this is also expecting one parameter. But now under this particular list interface, okay, under this particular list interface, now if you observe carefully what happening, it is expecting two parameters. The first parameter is index here. So second parameter collection. Second parameter is collection. Now what you observe carefully here, this is the list interface is going to have specific method which are going to have two parameters. The first parameter is going to play as the index role. The second parameter, it is going to play as the object, whatever the modification we are going to do. So if you see add all method, already we are having here boolean add all, but here if you see is expecting only one parameter. Okay, so what is the first parameter? The collection of values we are going to provide. But what about this particular list interface specific method, which is expecting two parameters? The first parameter is index, and the second parameter is collection. First parameter is index, second parameter is the collection of values. We'll see later how this particular list interface is going to be implemented, this type of methods here. Okay, so this is the first method. Now before going to discuss about this, so what is the purpose of this particular list interface? Now what you need to understand here, you need to read this particular messages so that we can easily understand what exactly this particular list interface is going to perform the various operation. So now by default, this particular list internally it is extending from this particular collection interface. Now here the elements are going to be inserted or accessed, so based on the proper position. So how we are going to insert it, in the same order we are going to be load this particular values here. Okay, so this is what we need to understand here. Now if what you need to understand, basically this entire collections, the entire list related whatever the collections we are going to implement here, so those are the purpose of this particular list interface. However, like whatever the order we are going to insert it, in the same order we'll try to load this particular values. Along with this, now it may contain some duplicate values here. It may contain some duplicate values. So this is what we need to understand. Now how we are going to get the same order, because internally this list concept is going to use one of the important concept called arrays concept here. Okay, so because of this only we are working on the index here. Now what you observe, the list related collections here, internally it is going to implement it based on the arrays concepts. We'll see how this particular arrays concepts are going to be implemented here. Okay, so now this is what we need to understand here. Now go back to the whatever the specific method we identified here. Now this is the first method we observe here, which is expecting into index. Second one is collection here. Now what about this one? Remove all. This is coming from the same collection interface. Here you can see remove all, which is expecting only one parameter. Now what about this particular retain all? Retain all also, which is coming from the same the collection interface. Okay, so collection interface methods we are not going to discuss as of now. So directly we can discuss with the implementation. Now if you see replace all basically it is one of the default method. Now we'll see how this particular replace all method is going to be used here. Now, so do we have any replace all method? Now here we don't have a default method here. Here you can see retain, like a remove if we are having. Okay, and this is the default method. Now, so this is the specific default method which is implemented under this particular list interface, replace all here. Now, another important section, sort method. Another important section, sort method. So this is also we'll discuss once we observe the each and every implementation classes here. Now here you can see clear method. This clear method is coming from the same whatever we discussed in the yesterday class here. Collection interface. Okay. Now equals method. So this is also same hash code method. We'll see how the each and every equals and hash code method is implemented. But this is the specific method which is does not have under this particular collection interface something like a get method. Something like a get method. Now if we observe carefully here what we are providing, index we are providing. So whenever we are providing an index, internally it is trying to returning as a E. So what is a E basically? It is a generic type. Okay, it is a generic type. So this is what we need to understand here. Now, what you need to understand basically, whenever we are calling this particular get method, here we are going to provide the position so that in the correct index location, whatever the value we are having, the value it is going to return here. The value it is going to return here. This is what we need to understand. Now, another specific method, if you observe carefully, set method. So carefully observe here, set method and get method. So get method is expecting index, and the set method along with the index is expecting the element also. So carefully observe here. If you observe carefully, add method directly without providing the position. Now it is inserting the record. So where it is going to insert it? From the 0 position onwards. From 0 position onwards here, it will try to insert the record here. But what about this particular set method? Based on the position, like based on this particular index location, it will try to insert the value. Okay, so this is the differences between, this particular differences between set method as well as this particular add method. Now if we go below, what is another method? Void add method. So carefully observe now. We are having one more add method. First add method is coming from the collection interface. Second add method is a specific method which is available only in the list interface. Now see the differences. This add method is expecting one parameter, and this add method now it is expecting two parameters. Now what you need to understand, this add method into index and element we are providing. Okay, into index and element we are providing. So based on the index location, so we are going to provide this particular element here. Okay, but another important section, now if you observe, so set method is also expecting two parameters and add method is also expecting two parameters. But what is the differences between these two? So set method, whatever the element we inserted, the element is going to be written here. The element, it is going to be written here. Okay, so this is what we need to understand here. This is what we need to understand here. Now, the void method, it is not going to return any values. The void method, it is not going to be written any values. So this is what we need to understand here. Now, remove here. So carefully observe, this is the specific method which is available only under this particular list interface. Now you can see we are having remove method. So this is a Boolean method. This is the Boolean method. Boolean remove method we are having. But here, this is not a Boolean method. It is trying to return as a E. So if you observe carefully, the generic concept is how it is playing an important role here. So E is something like a element here. Whatever the element we are going to insert here, the particular element is going to be written here. The particular element is going to be written here. So this is what we need to understand. Now here, using this particular remove method, here we are providing the position. In the proper position, whatever the element we are going to store here, the particular element is going to remove. And here, using this particular remove method, we can observe what is the element is removed. But here, using this particular remove method, we are passing an object. We are passing an object. the particular object is going to remove. But here we are not passing an object. We are passing position. In which position element we want to remove. So now if you see, for this particular list related interface, each and every method it is going to play as a position role. So that is called index role here. Now index is going to play a very important role for all the list related methods here. For all the list specific methods, because inside the list interface we may have collection related methods also, because the list interface internally it is extending from this particular collection interface. But here, even though if it is extending, but whatever the specific method we are having, for all the each and every specific method internally, it is going to play as a index role here. Okay. So now observe carefully here int index of. Now as of now, if you see here, we don't have any index of method. Here we don't have any index of method. Now what you need to understand here, this method is a specific method. Here we are providing the object. Here we are providing this particular object so that we can observe this object is located in the which index location. Okay, so this is the main purpose of this particular index of. Now what you observe here, this method it is going to return the position of the current object. Position of the current object. So this is the object as a parameter we are passing. Whenever we are passing object as a parameter, now we can observe where exactly this particular object is resides here. Where exactly this object is resides here. Now you can see here the differences between index of and last index of. We already discussed in the string related and string buffer related classes. So what we need to understand here, if this the current object is repeatedly coming, for example, the same object is coming as a 3 times. Now the first occurrence is going to return by this particular index of, and the last occurrence is going to return by this particular last index of. So this is the important method. Now if you observe here, we are having a method. So this is a array concept here. Now what you need to understand here, this is some values I'm trying to providing. Now here I'm having a, and here also I'm having a, and here also I'm having a. Now using this index of method, so whenever I'm providing the objective, in place of this particular object, if I provide a value, it will return as a this particular position. For example, this is the 5, and this is the 10, and this is the 15. Now the index of method it will try to return as a 5 here. Now whenever we are trying to discuss about this particular same last index of here, and here the parameter again if I'm trying to pass as a, it will try to return as a this index location 15. Okay, because this is the last occurrence of this particular given object here, and this is the first occurrence of this particular given object. So this is the differences between index of method as well as last index of method. This is what we need to understand here. Okay, now we'll discuss more about this particular internal implementation of index of and last index of, how it is implemented. Now, so this is the specific method which is available only under this particular list interface. So what you are observing here, list iterator. Okay, so this is the list iterator. Now this is the specific list iterator we are going to use for this particular list interface here. Now this is a method. Now we'll see the differences here. Here we are calling iterator method. Now it is trying to return this particular iterator. So same way we are having list iterator, internally it is trying to return as a list iterator. We'll see how these two interfaces are implemented internally. So to understand this is having so little bit more methods compared to this. Now you can see internally it is extending from the same iterator. So yesterday we already observed this iterator interface here. So from this particular iterator, now it is extending from this particular one more interface called list iterator. Now here you can see as next we already identified, next we already observed. So now what is the important here? As previous, the previous one, and here next index and previous index. So these are the abstract methods. So here you can see set method, add method we are having. We'll see how this particular abstract methods are implemented internally under this particular list iterator interface here. Okay, we'll come back to here once we completed the collection framework structure here. Later we'll discuss about the iterator as well as list iterator here. Now coming back to the below method. Now if we observe sublist, so what exactly this particular sublist is doing here? Now what is the purpose of this particular sublist? The name itself, it is providing the information. So what exactly it will do? For example, so this is a bigger array we are having. Okay, now I want to load from this particular values. Okay, now this position start with a 10. Now this particular position end with a 12. Now what you are observing is from index and to index. Now in place of from, if I provide 5, and if in place of this particular 2, if I give as a 12, now between how many characters, like how many indexes we are having, this particular indexes are going to copy as a new list. Okay, so now this is what it is trying to return here. It is trying to come up with a list type, so that what we can identify, it will try to create a new list concepts here. Okay, but sublist is nothing but based on the position, like based on the from index and to indexes, it will try to copy the element and it will try to create a new list objects here. Okay, so this is what we need to understand. Now if you are not interested, what you can do, directly you can provide the position here. So for example, I want to load from this particular file end of this particular collection. Now what you can do, you can call the size method, size -1 something, it will try to load this particular values here. Okay, so 5 to something like a 16. Now here from this particular position, it will try to copy all the values and it will try to create a new list object. So this is another important concept called sublist method. Okay, now if you go for this particular default method, we already discussed here split iterator, which is coming from here. So this is the one more split iterator. We'll discuss later what exactly it will do. Now if you see this off method, now we'll observe how exactly this off method is doing. Now if you observe carefully, so immutable collection dot empty list, whenever we are calling this particular OF method, like off method, internally, so what is returning? It is trying to return as this particular list type. But here, mutable and immutable. So what exactly it will do? This will try to create a empty list here. We'll discuss later how exactly this particular immutable list is going to be created internally. Okay, this particular off method we'll try to discuss later here. So now what I'm doing here, I'm trying to copy this off related method, and it is a static method. So whenever we are having a static method, directly without creating an object of this particular list interface, we can access this particular methods here. So this is a off method which is not expecting a parameter, but this particular off method, now it is expecting the parameter. Okay, so with this off method is a overloaded method. Now if you see one parameter, so this method is expecting 2 parameter, this method is expecting 3 parameter, this method is expecting 4 parameter, and 5, so something like a 6, so 7, and 8, and 9. Okay, so something like a 10. Now after this, if you still have a more values, then we can go for this particular method called varr concept. Okay, still we are having more values, then we can go for this particular varr related method here. So this is we already discussed in the previous example here. Now you can see these are the list related methods. So now what are the specific method we are having here? Now these are the specific method we are having under this particular list interface. Now what you need to understand, the entire list interface, it is going to be work on the indexes. This is very important. If you provide the proper indexes, the insertion and object loading and object insertion, it is very fast, because we are giving the direct position here. So it will try to insert into the proper position, and whenever you are providing the value, directly it will try to load from the particular proper position here. Okay, now what you need to understand, the last method, copy of method. So copy of method. Now We'll discuss later how this copy of method is implemented. So it is something like a cloning related concept here. It is something like a cloning related concept here. So one collection into another collection we are cloning here. Okay, so these are about the important method we are having under this particular list interface. So now, what are the main purpose of this particular list interface? It will try to insert it and access it based on their position. Position is nothing but indexes here. Okay, so this is the main purpose of this particular list interface. Any questions? Anyone having any questions? Okay. So now, if we don't have, now we'll discuss about the another important interface here. So first, so far we discuss about the collection and list we discuss here. Now we need to discuss about the set here. So now, if I show you this particular set, again, this particular set internally, it is extending from this particular collection. Internally, it is extending from this particular collection. Now here, what I'm doing here, so I'm trying to paste as a this particular set related concept here. So carefully observe. Now here, what is the method we are having? Size method. Now here you can see size, it is already come from this particular collection interface. Okay. Now, so same size method I'm pasting here. Now, boolean is empty method. Okay. So these are the same method which is already available under this particular collection interface. Now here you can see contains method. Okay, iterator method. So object array. Okay, now you can see, now this is the one more method, the type related. Now this is we already observed in the yesterday class. Now add method. Now carefully observe all the methods are same method because there is no specific method under this particular set interface. So far, whatever we discuss here, all the methods are available under this particular set interface. But what exactly this particular set interface is going to do? So set again internally, it is extending from this particular collection and it is not going to allow duplicate elements here. So this is very important here. So now here in the list interface, so the duplicate section is going to be allowed and whatever the position, like however we are inserting in the same order, we are going to load the values. But here, whatever the whatever the way we are going to insert it, the same way we are not going to get these particular values. So we'll see why we are not going to get the same the order however we inserted here. Okay, but now observe carefully. So contains also method we are having. Now this is the same method which is we already added under this particular collection interface. Okay, now you can see add all method and retain all method and so remove all method. Okay, so now here you can see clear method. So same methods, whatever we are having under this particular collection interface. So all the methods now we are using here. So there is no, so as of now there is no specific method. If we have, we may have the static or default methods here. Now you can see, so set off. So this is the one specific method which we are having under this particular what we can call it as a set interface, set off method. Now same way here if you see list of method and here we are having off method. Basically this off method it will try to return as a set interface and this particular off method internally it will try to return as a list interface. So this is all about the important concept here. Now so again it is one of the overloaded method. So one parameter, two parameter, three parameter and four parameter up to 10 parameters here. Now here you can see so up to 10 parameter. So once the 10 parameters are completed, now it will go for the one of the important concept to call varchar. Now and copy of method. So this is the common method. So this is something like a copy of method. Already we have under this particular list interface. The same copy of method is available under this particular set interface. Now, so once we discuss one method, now we can easily understand the another copy of method here. Okay, so this is what we need to understand here. Now, these are the methods we are having under this particular set interface. Now, if you see up to this, these are the same method which we have already identified under this particular collection interface. But currently, only the few specific method we are having. So those are of method and copy of method. So of is one of the overloaded method we are having. So 0 to 10 parameters are going to be taken care of. Okay, and another one is copy of method. But if you see the hierarchy, how it is going to be implemented. So to understand this, how this particular hierarchy it is going to be implemented. So far, we discussed about the two interfaces. Collection is a root level interface, and one side it is extending from this particular list here, and another side it is extending from this particular set interface here. Okay, so these are the current hierarchy we observe here, but still we are having few more interfaces here. So sorted set. Now if we observe, this is a sorted set. Okay, now if you see from this particular set, now internally we are extending one more interface called sorted set here. So we'll observe how this particular sorted set is going to be implemented. So carefully observe the hierarchy now. Root level interface is collection, and collection internally it is extended by set, and set internally it is extended by this particular sorted set here. Okay, now we'll observe how exactly it is going to do the sorted set. So sorted set, so it is going to provide the ascending or descending order. The elements, whatever the elements we are going to insert it, if you need the proper order, like either if you go for the ascending or if you go for this particular descending order, so we can go for this particular sorted set here. Now what are the specific method we are having this particular sorted set here. So we'll see what are the important method we are having under this particular sorted set here. Okay, so now observe carefully. Here I'm trying to comment out this particular set here, and this is a sorted set here. Now whenever I'm trying to show you this, now you can observe carefully sorted set and internally extending from this particular set interface. Now if you see this, what is saying is basically it is the set that provides the total ordering on this particular element here. So internally what is saying here, it is also one of the set related concept here, but it is going to provide the ordering here. Okay, so these elements are ordered using the natural ordering. But here we need to understand the one important concept. So to get this particular natural ordering, we need to go for the comparator or comparable. Okay, so we already discussed about the comparable, which is having only one method called comparative method. Okay, we'll see how this particular section of this particular comparator is going to be used. But what you need to understand here, you need to understand what are the specific methods we are having. So let me copy this first. Okay, sorted set. Now here, the first one, if we observe comparator. Okay, so far we did not discuss about this particular comparator. Now here if you see what exactly this comparator is doing here. Now if you read this, it is going to call internally compare. Okay, less than or equals to 0, equals to 0, and one more we are having greater than condition. Okay, now basically, so it is going to take care of the ordering some collection of objects here. So this is the main purpose of this particular comparator. It will give you the greater than, less than, or equals values. Greater than, less than or equal values. So we'll see comparator is one of the functional interface because the comparator is having only one and only one abstract method, that is called compare to. He is expecting two object as a parameter. First one is T, like O1 and O2 here. O1 and O2 here. So this is what we need to understand here. Now another important section here, if you see, now here this is the default method. Reverse here. Okay, it will try to provide the reverse order. Now another important section, then comparing. So this is also one of the default method. Now this is the one more than comparing. Maybe it is expecting different parameters here. We'll see this default methods. But first what we need to understand is this comparator, how it is going to provide internally. Okay, the first method comparator we need to understand. Now second one is subset. So the name itself, it is providing this particular information. Now what you observe carefully, subset is nothing but whatever this particular sublist, whatever this particular sublist we identified, same way it is going to work here. Now here you can see from element and to element. So here we provided the positions, sublist. For this particular sublist, what we did, we provided the position. So which index onwards to which index, so that the between all the objects are going to be copied and it come up with a new objects here. But here if you see here the subset method, it is basically sorted set, it is not going to be work on any indexes. So directly it is going to work on this particular objects here. So because of this, what you need to understand here, here we are giving the from object and to objects. So objects is nothing but from element as well as to element. Now based on this, now what we can observe carefully here, here we need to observe the how this particular subset is going to be created. Based on the from element and to element, between how many elements we are going to have, all the elements are going to be copied and it will try to come up with a new object, something like a sorted. So this is the main purpose. Now if you see the on top of the each and every method, we'll get the different type of exception. So now you can see class cast, null pointer, illegal argument. Okay, we'll see later how this each and every method is going to implemented this type of exceptions also. Okay, now headset. So what you need to understand here, these are the specific method. Okay, these are the specific method we are having. So subset we observe here. Okay, headset. Headset, if you observe two element. Now what you observe here, now here if you see strictly what you need to understand here whose elements are strictly less than this particular two elements. Here, what is the condition we are using here? Less than condition. So less than condition to this particular element here. If any elements, those are less than to this particular parameter element, whatever the parameter, method parameter we are going to pass, if any match records, so those are less than to this particular elements here, all the records are going to be copied and created a new sorted set object here. Okay, new sorted set object. But what we need to understand here, this particular parameter, it should check each and every condition, like each and every object is going to check whether this object is less than or this object is less than or something like greater than or is something like equal. So this is what we need to understand here. Now carefully observe. Now carefully observe what exactly it is going to provide this particular section here. Headset here, less than condition. Now tail set. Now if you see this, so one more method we are having, tail set. Now what exactly this particular tail set is doing here? Here you can see, so greater than or equal. Greater than or equal. Now, so greater than is nothing but this is the concept. So greater than or equal to from element. If any records are going to match with this particular greater than or equal condition, so those records are going to be fetched and created as a sorted set object. Okay, so carefully observe less than and greater than or equals to. Now tail set is completed. So what about this particular first method will do? The first method, it will try to return the current the first occurrence of this particular element here. Okay. So from this particular sorted set, the first element, whatever it is going to be available under the sorted set, it will try to return. Now same thing, it is applicable for this particular last also. But here if you see, return the first lowest element. Okay, lowest element. Now here you can see return the highest element. So this is important here. Something like a highest element here. Now first to lowest element. Now why I'm saying this particular description, because we are having similar methods. In the sorted set, we are having similar methods here. Now carefully observe. If I'm going down here, we'll observe what are the similar methods we are going to get here. So far, if we observe, these are the specific method we are having under this particular sorted set. So first method, subset here, and head set we are having, and tail set we are having, and so first and last here. Okay. Now, so similar method we are going to use in our another interfaces here. So for what are the hierarchy we observed here? First one is collection. From the collection, we observe the one time list here. So second time we observe the set, and set internally it is extending this particular sorted set here. But now this sorted set internally it is extending from one more interface called navigable set. Okay, navigable set here. So what exactly it is going to provide this here? So carefully observe. So how this particular hierarchy is now having here. So set to sorted set to navigable set. Now inside the navigable set, we'll have a collection related method, and set related method, and sorted set related method, as well as if we are having any specific method under this navigable set, so those also it is going to have under this particular navigable set here. Those also now it is going to have under this particular navigable set here. This is what we need to understand here. Okay, so carefully observe how it is going to be, have this particular section of code here. Now coming back to here, this particular navigable set, how we can discuss about this particular concept here. Let's observe. Now you need to discuss about the navigable set. Now here you can see navigable set. So whatever I suggested, navigable set internally, it is extending from this particular sorted set here. Okay. Now what you need to understand here. So this particular sorted set, it is extending with the navigation method. So reporting, its closest matches the given search. So based on this particular search, if any one of the particular search criteria is matched here, so the values are going to be written here. Now these are the different type of method we are having under this particular navigable set classes here. Now basically, now if you observe, the navigable set may be accessed and travels like from first element to end element to first element. So it is going to be travels in the both direction, like ascending as well as descending orders here. So now because of this particular ascending and descending, we are going to use this particular navigable set here. So if you see, so it is going to have a different type of method. The first method, lower. So carefully observe, this is the first method we are discussing, lower method. As of now, we could not identify the lower method. Now what is saying here? So if you see, it is going to return the greatest elements. It is going to return the greatest element, but what is the condition we are having it? Now, what is the condition we are having? It's strictly less than the given element or null. If so, if any condition is not satisfied, it will return as a null, but the condition should satisfy less than the given element here. Okay, given the less than element. Now if you see, whenever you are calling this particular lower method, here we are passing the parameter as a element type here. Now this element, it should be less than the given element. Whatever the navigable set we are having. For example, navigable set we are having these many objects. Okay. So here I'm giving 10, 15, 20, 25 and 30. Now I given something like a 20. Now this particular two conditions are going to be satisfied. These two conditions are satisfied. But in these two conditions, which is the highest value? The 15 is the highest value. So this 15 is going to return by this lower method. This 15 is going to return by this particular lower method. So this is the lower purpose of this. Now what you are observing is, it is going to return the greatest element, but the condition less than to this particular given value. Okay, this is what we need to understand. Now what about this particular floor method? If you see, again it is also written the greatest element, but here the condition less than or equals to the given element. Less than or equals to this particular given element. But so now what you need to understand here, this particular method strictly is checking the less than the given element. This particular method strictly checking this particular less than the given element. But this particular floor method, now what is the two conditions we are having? So it is checking less than or equals to the given element. Okay, so now it is going to check less than or equals to given element. So this is the differences between lower as well as floor method. Now if you see, so ceiling method. Now what exactly this particular ceiling method is doing here? Now same thing. So here also expecting the element as a parameter, it is trying to return as a same element, but conditions are different here. Now here you can see this greater than or equals to the given element. Greater than or equals to the given element here. Now observe carefully, less than condition and less than or equal condition are greater than or equals to this. Okay, so this is the less than condition. So this is the less than or equals to condition, and this is the greater than or equals to condition. Okay, these are the important method. So this is something like a ceiling method. Now what about this particular higher method? Now observe carefully, higher method, how it is trying to return. So strictly greater than the given element. Strictly greater than this particular given element here. So now observe carefully, it is something like only greater than. Now less than and less than or equals to, greater than or equals to, and greater than. So each method is doing differently. Each method, the purpose is differently here. So this is something like up to higher. Now what about this particular pull first method? What about this particular pull first method? What is doing it? Now if you see this, it retrieve and remove the first lowest element. Okay, it is going to retrieve all the values, but it will try to remove the first lowest element from this particular the navigable set here. Okay, it will try to remove this particular value. If we are not having any elements, it will try to return this particular values here. So now you can see it is going to retrieve. It is going to retrieve and remove the first lowest element here. But how we'll get the lowest element? Again, we'll do the ascending or descending order. So based on that, we'll get the lowest element. The particular lowest value is going to be removed here. But as of now, you cannot understand what exactly it is doing it. But we'll understand whenever we are trying to discuss about the implementation concept here. Okay. Now you can see this. So same here. Now this is also, but here it will try to remove the highest element. It will try to remove the highest element here. This is what we need to understand. The lowest element is removed from this particular pull first method. The pull last method, it will try to remove the highest method. Okay. Now you can see iterator. So no need to discuss about the iterator, which we are going to discuss in the collection related here. So now you can see descending set and descending iterator. We'll see this descending iterator, but if you observe descending set, what exactly it is doing here. Now if you see, returns the reverse order view of the element. Okay. Now, whenever you are calling this particular descending set here, simply it is trying to return the reverse order. Okay. This is the main purpose of this particular navigable set descending set method. Now, descending iterator. Now, what we understand here, we'll get the reverse order elements here. Okay. We'll get the descending order. Now, another one subset here. So now we already discussed here subset. So see carefully, subset is expecting two parameter from element and to element. But inside the navigable set, inside this particular navigable set, again we are having same subset here. But what are the parameter is expecting? From element and from inclusive. To element and to inclusive. Now what is saying here? This Boolean flags here, if we want to include the current element or not. Now if you read this, so here from include, if you provide the true, if the low endpoint is included in the return view. Now what you understand here, if we want to include the from element also, then we can provide this particular true as the second parameter. Now if you are providing false, this particular from element, it is not going to be included. So this is only the differences between the subset method from this particular sorted set. Okay. So now if you see, navigable set is expecting 4 parameters, but sorted set is expecting only 2 parameters. But here it is not going to include these two. But if you provide this particular Boolean flags as a true, now from element as well as two elements also it's going to be included. This is the main differences between the sorted set subset method as well as navigable subset method. Now come back to your edge set. So carefully observe. So now if you see, here we are having edge set method. What is doing it? Here this edge set method is expecting less than this particular elements here. Okay, but here what we are having? Sorted set. Now here also same, the same edge set will do the same, but only the difference is here it is having one more parameter. So carefully observe here, what is the one more parameter we are having? What is the one more parameter? Two element we are already providing here also, but inclusive. If I want to include this particular two element or not, we can provide here. Okay, here this method is not going to be included, but this navigable set is going to be included. This is the same, but here the condition, if you see, navigable set retrieve the view of the position of set whose elements are less than. Okay, less than. But here if you see, R condition, R equals to if inclusive is true. If inclusive is particular true, when we are providing this particular values true, it is going to check as a less than or equals condition. So this is only I am saying. So after otherwise it will not include this particular element, but in the navigable set it is going to be included. This is the same method. Now same thing it is applicable for this particular tail set. So now we are discussing tail set. Same method here also we are having here. Okay. So now tail set here greater than or equals to from this particular element here. Now going back to here, now below method subset. So same subset we are having here, which is coming from this particular sorted set method. Now here you can see head set, same head set here, and tail set, same tail set here. So these are the important methods under this particular navigable set here. If you see, so this navigable set mainly it will work on the less than or equals to greater than or equals to conditions only. So whatever the method we discuss here, all are having less than condition, greater than condition, less than or equals to, greater than or equals to. So these are the main conditions we are having there. Okay. Now so far these many interfaces we discuss here. The first one is collection, second one is list here, and third one is set we discuss here, fourth one is sorted set, fifth one is navigable set here. So these are the one set of interfaces. So still we are having few more interfaces here. So those interfaces will continue tomorrow. So once the interfaces are completed, first we'll discuss about the abstract classes. Okay, abstract classes. Now later we'll discuss about the implementation classes here. Okay. Any questions? Still anyone having any questions? Okay. Now if you don't have anything, so I'm stopping the session up to here. We'll discuss in tomorrow session.